Good morning, everybody. Welcome to another Monday morning of Chem 1105 with your host, me, Dr. White. Hope you all had a nice weekend, like I just said I did. All right, important announcement. Number one, on Friday, I will be giving test number 2 during our lecture time. We won't actually have a Zoom meeting at about 9:55, I will send out an email with the password for the version of test number 2 that you will be taking. You'll have until 11:30 to take it and upload your answers as a single PDF file. I reserve the right to subtract up to 25 points if you don't upload it as a single PDF file. I highly recommend before you upload it, check and make sure it opens. Some of you sent me stuff in the past with labs that I can't open. Oh, that's still good. And don't forget, check to make sure you've got all your answers in that file. I've had people who've forgotten to put in a whole page. I was nice enough to go back and tell them you need to do this, but if I didn't want to be nice, you could lose a lot of points. So check. That's Friday. Announcement number 2. Tomorrow at College of DuPage, it's called In-Service or Professional Service Day. I think it's got both names. And that means there's no classes. You can all go, yay. No, you don't have to, but you could. And therefore, we will not have a Zoom meeting, no Zoom lecture, no Zoom lab. You got the day off from me. Yay. No, anyways, you don't have to do that. So remember, don't show up tomorrow. What I probably will do is for the first 10 minutes, for those of you who forget, I'll have a sign up, no class today, in-service day. So remember, labs are due the next lab period after the one we've added. So last week's lab is not due tomorrow because there's no lab. If you want to turn it up in, you can. It's due next a week from tomorrow because that's our next lab. Uh-oh, 3 and 5 minutes. I'm really into Cheeto morning. All right. Also, over the weekend, one of the things I did do was I graded labs, and I believe anything you've turned in, well, I think more than I believe I know, anything you've turned in should be in Blackboard a grade. If you see a 0 there, you never turned in a lab and you missed the amnesty program. In the future, make sure you turn your labs on time. Any questions before I start an exciting morning of chemistry? I'm looking at the chat area. All right, let's get going. Remember tonight from 5 to 6:15, I will be having my office hour. If you need any help, stop by and say hello and get the help. Don't forget, if you don't know how to do scientific notation on your calculator, doing multiplication and division, you're going to be in a world of hurt on Friday. Come to my office hours, Wednesday or Thursday. I was going to say tomorrow after a lab, but there's no lab. So Wednesday or today, not Thursday, stop by and I'll show you how. All right, let's get going. Now, last Friday, I started teaching you about the ideal gas law. And the ideal gas law is PV equal nRT. And if you look at the very bottom of the slide, it says, learn this. I didn't even have to print it on the page. Notice, not 1, not 2, not 3, 4 exclamation marks. You should learn this. Now, PV equal nRT. P is pressure, but the units have to be in atmospheres. V is volume. The units have to be in liters. Don't tell anybody, but in my problems, we'll always use liters, so you don't have to know how to convert from milliliters to liters. Thank you, Dr. White. You're welcome. N is the number of moles. You know moles. And T is temperature in Kelvin. If it's not in Kelvin, this will not work. And R is called the universal gas law constant. And for our class, we'll use these units and this value, 0.0821 atmosphere liters per mole Kelvin. This is a calculated number. You actually go in the lab and determine it. And if you notice, the one I'm using has how many? 3 significant figures. And that's important to remember. All right, let's have fun with PV equal nRT. Yep, 15 points. All right, let's look at this. Yes, don't forget, PV on RT and gases are for test 3, not test number 2 this Friday. So 15 points. Woohoo! What is the volume of O2 oxygen gas in a balloon if you have 18.5 grams of oxygen at 24.2 degrees Celsius and 752 torr? Well, you know what to do first. What are we being asked to find? Volume. I'm going to use V. What are we given? Well, we have 18.5 grams of O2. The temperature is equal to 24.2 degrees C. And the pressure, remember, torr is a unit of pressure, so is millimeters of mercury, is 752 torr. So what do we do? Well, if you notice, we're dealing with a gas. And is anything changing? No. But we're given a weight, a temperature, a pressure, a volume, and hint, hint, and therefore you should use the ideal gas law. PV equal nRT. Now, I just remembered I should have done something. And if you look at your screen, you see ideal gas law, PV equal nRT. P is pressure in atmosphere, V in volume, liters, and moles, T temperature in Kelvin, and the universal gas law constant. I think somewhere up here, over here, I have the K equals degrees C plus 273, and 760 torr equals 760 millimeters of mercury equal 1 ATM, otherwise known as atmosphere. And this is from important information, test number 3. So you don't have to memorize this, you'll be given it. That's why I've cut down on memorization. I'm stressing learning so you know how to learn and show me you've learned how to use this, not how good your memory is. Speaking about that, time out for a quick announcement. Before test number 2, I'd highly recommend you look at test number 2, important information, which is in the lecture folder of Blackboard. So you see what things you should know how to use. Hint. All right, so if we look here, we have PV equal nRT. What are we being asked to solve for? Value. Well, here it is, but we have to get it alone on one side. So everybody take a deep breath, let it out, take a deep breath, let it out. We're going to do some algebra, relax. And now, how do we get V alone on one side? Well, anything divided by itself equals the number 1. So if I want to get rid of P, well, if I divide this by P, that will cancel out. Whatever you do to one side, you have to do to the other. And anything divided by itself cancels out. So I now have V equal nRT over P. So R, remember we were given, it's an important information. R is 0.0821 mole atmospheres liter mole K. So we got R. How do we get N, T, and P? Now, what is N? Well, in case you forgot, let's go back to important information. And N is the number of moles. Well, up here, important information, 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights in that compound. So if we go back to our problem, if I want to find moles, I have 18.5 grams of oxygen gas. What do I want to get to? Moles of oxygen. And now it's time to use your good buddy, your good friend, unit analysis. I love that whistle. For those of you who don't, send me a nasty email. Don't use it. For those of you who do, send me a nice email. Please use it. So using unit analysis, whatever we're trying to get to, we write on top. Whatever we're trying to get to, we write underneath. And where do I get these numbers for that relationship? 1 mole equals the molecular weight of oxygen. The molecular weight of oxygen is 2 times the atomic weight of oxygen, 2 oxygen atoms. And if we look at our periodic table, and for test 3, just like test 2 coming up this Friday, it will say under your name, please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic weights. Oxygen, I'm going to let you figure out what's the atomic weight of oxygen, the three significant figures. Time's up. Oxygen right here, the atomic weight is the number underneath, 15.999. This is the periodic table you'll be given for test 2 and 3, 4 in the final. And rounding that off, the three significant figures, keep the 1, keep the 5, keep the 9. Second 9 used to round off. That's 5 or higher. Drop those last two 9s. Increase the 9 by 1. That'd be 1.0 plus 15 is 16.0 is the atomic weight of oxygen. And therefore it's 32.0. So I have 32.0. And now I'm going to pick up my calculator, turn it on, clear it. 18.5 divided by 32.0. And my calculator gives me a long number. I'm going to round it off to three significant figures. Why? Three significant figures, three exact number. And that's how many moles of oxygen gas. So we have N, we have R, next is temperature. But before I continue, let me explain something important. When you're doing a multiple step calculation like this is, there's two philosophies. One is round off at each step. That's what I do. And the other is wait until the end. Now, I'm a round off at each step person, but I'm not going to force you into one way or the other. And on the test and also the practice problems, I won't do it now. I will round off either, both ways, not either, both ways, and either answer, if they're not the same, will be correct on my test. So if you're not a round off at each step person, I'm not going to force you to do it the way I do it. I'm not going to say it's right or wrong one way or the other. It's just good habits I don't change. And it's been good to me for many decades. Ooh, that hurt. Shouldn't have said that. So now let's move on to temperature. And temperature for PV equal nRT has to be in Kelvin. But we have Celsius. So what do? Well, Kelvin equals degrees C plus 273. And this is 24.2 plus 273. And we get 297.2 Kelvin. Why 0.2? When you're adding, you get the same number of significant figures to the right of the decimal as the number that has the fewest. This has 1. This is an exact number, so you don't use that to determine significant figures. And therefore, that's why if I did my math correctly, and I did, this is the correct answer. Don't forget that 0.2. All right, so we've got N, R, T. What's left? Pressure. And if you look at important information, test number 3, which we will now, you'll see pressure is in atmospheres. And if we scroll up, notice 760 torr equal 1 atmosphere. So now let's go back to our calculation. And by now, I think you're figuring out why this problem is 15 big ones, because there's a lot of work to do. And we want pressure in atmospheres. but we have it in torr. And we want to get to atmospheres. And now we'll use our good buddy, our good friend. No, I'm not going to use the whistle again. You'll get whistle overload. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. I'll write those in. Where do I get those numbers? And I'll show you again. 1 atmosphere equals 760 torr. So for every 1 atmosphere, there's 760 torr. Notice torr cancel out. I forgot to do this, grams and grams of oxygen. I should have, bad Dr. White. But anyways, torrs cancel out and we're left with the units we want. Now remember, 1 and 760 are both exact numbers. And here we have 3 significant figures. And our answer should be 3 significant figures. And now I'll go to my calculator and take 752 divided by 760. And my calculator gives me 9.89, and I have 473682, but I'm going to round it off, and this is a 9 times 10 to the minus 1 atmospheres. So I now have P in atmospheres. Am I done? No, I have to come back to this. V equals nRT, and we figured out is 5.78 times 10 to the minus 1 moles. R is the universal gas law constant. And let me do something. Give me a little more room. And T is 297.2 Kelvin. Let me give you some more room. And then on the bottom here, we have 9.89 times 10 to the minus 1 atmospheres. And now if we look above, before we pick up our calculator, forget about this under the 9.89. Just look at the top line. You have moles and divided by moles. That cancels out. You have Kelvin divided by, it's pretty small, but Kelvin, that cancels out. Now on top of, we have our atmospheres, liters. Underneath, we have atmospheres. That cancels out. And all we're left with is liters, which is a unit of volume. We're on the right track. So now let's clear my calculator. And I'm putting in the numbers. And my answer is 1.42, and I have 601.3 something. I'm going to round this off to 3. Let me just show you first. And this should be 3 significant figures, 3, 3, 4, 3, which is the lowest number of significant figures. It's 3. So I'm going to let you round this off to 3 significant figures. I'll give you 3 seconds. Go. Time's up. Keep the 1, keep the 4, keep the 2, use the 6 to round off. As 5 or higher, I'll drop that. Increase the one front by 1. So that balloon has 1.43 times 10 to the 4th liters, or 14.3 liters. Wow, that's a lot of volume for only 18.5 grams of oxygen. All right. Any questions on that? Now, I'll remind you again, and this is also important for test 2 this Friday. Show your work. I know some of you have typed on either the PDF file I send you or the Word document, but this is one of those times, both test 2 and 3 and 4 in the final, it pays to show your work. What if you made a mistake on one of these? What if you got this for moles, you did the math wrong? Well, if you show your work, I can check and say you did that. Like you punched the wrong buttons on your calculator. If I see work, I see a mistake like that, I will say, oh, math error. And if everything else is right, I'll give you 14 out of 15 points. If you just show me an answer and it's wrong, I can only give you 0 points. In other words, nothing. So it always pays to show your work. Now, this is my own personal opinion, and I'm stating as such. For a number of years now, car dealerships have been pushing, don't put air in your tires, put nitrogen gas. It's better. I don't think so. That's my personal opinion. I understand why, because oxygen gas will attack certain things in your rubber tire. And it's under pressure. So when you put air as opposed to nitrogen, that might accelerate, make it go faster, just a little. Well, the reason I don't buy into that is on the outside of your tires, guess what? There's air. I'm breathing it, and I hope you are too. And that has oxygen, nitrogen. That can also mess up your car tires with, how should I say, time, long time. But you can find or buy, go to your dealership, and most also car tire places, I think, do too. I don't know. I use compressed air. You go to the gas station. One of these days, I'm going to have to buy my own compressor. But let's look at the following problem. All right. A car tire has 9.87 liters of nitrogen gas at 25 degrees C and 748 torque. Storm's coming in, that's why the pressure is not 760. And tonight or this afternoon, there is one coming in. All right, what is the weight in grams of the nitrogen in your tire? Well, how do you do this? Well, hint, second hint, but if you look at this, we have what is the weight of the nitrogen? We're given a volume. We're given a temperature. We're given a pressure. As soon as you see this, and you're dealing with a gas and nothing is changing, pressure, temperature, or volume, and hint, big hint, you know it's PV equal nRT. But wait, P is volume, P is pressure, V is volume, got ahead of myself there. N is moles, R is the universal gas law constant, T is temperature. How do I get grams? Well, this you need 2 steps. Step 1. And the reason I keep on putting that, making sure it's lowercase in organic chemistry, capital M, and also in general chemistry, capital N, means something else. All right, step 1, you have to determine how many moles of nitrogen you have, which you can do from PV equal nRT. Step 2, convert moles of nitrogen to grams of nitrogen, which you better know for Friday. And so let's get to work. Step number 1. Determine moles of N2. PV equal nRT. I want to solve for N. And I'm going to let you try that. Just with that equation, why don't you try and get N alone on one side? Your turn. All right, excuse me, time's up. How do we get N alone on one side? We have to get rid of R and T. And remember, anything divided by itself equals number 1, meaning it's gone. So if I want to get rid of R and T, I'll divide it by R and T. But whatever I do to one side, I have to do to the other. I've done that. R divided by R is 1, it's gone. T divided by T is gone. So I now have N equals PV over RT. And I'm going to rewrite that because I like to do that. And good habits I don't change. Now we have to find pressure, but it has to be in atmospheres. And if we look up here, we have 748 torr. And we want to get the atmospheres. So I'm going to let you figure out what goes here and here, units and number wise, but I will help you out. Oh, Dr. White's pulling a winky dink on you. How about if you looked up winky dink in YouTube? Give you 10 more seconds. Hurry up. I'm looking at a watch for the seconds. Time's up. Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, the units go on top of a ratio. Whatever we're trying to get rid of, the units go underneath. Where do we get these numbers from? Here. First of all, I'll write this in. 1 atmosphere is 760 torr. Remember, this is an exact number, and this is an exact number. And now I'll pick up my calculator. Make sure I clear it. Again, I'm a round off at each step, so I'm going to round this off to 3 significant figures. All right, so we have pressure. Next, we need volume. Well, that has to be in liters. And good news, you're given that in liters. And that's a bad looking one, but let's call it 9.81 liters. Well, next, R, well, that's the universal gas law constant. And if you look at important information, test number 3, I give you R, so you don't have to memorize it. And finally, temperature has to be in Kelvin, which Kelvin equals degrees C plus 273. We have 25 degrees C plus 273 equals 298 K. So now I'm going to come back and write N equal PV over RT. I'll have 9.84 times 10 to the minus 1 atmospheres. I have 9.81 liters, 0.0821 atmospheres, liters, mole, Kelvin, and I'll have my temperature, which was 298 K, Kelvin. Now, notice if you forget about this bottom line here, atmospheres cancel out, liters cancel out. And what we're left with, and this is some high level math, but I figured I'll show you, you're left with that. And that's really equal to mole times Kelvin. 1/1 moles K is equal to this. So we now have this on top. We have Kelvin underneath, so that would cancel out right there. And what are we left with? We're left with 1/1 moles, which is really equal to moles. So units cancel out. This is a little tricky on the unit part, I'll be honest with you. But good news, your instructor was a math minor as an undergrad student at IIT. Why? Because it was fun. The multiplying stuff. And my calculator gives me this number. Oops. And notice this is 3 significant figures. 3, 3, 3. So round this off to 3. So we have, actually that was N2, I was right the first time. And this is one of those, in a test, I calculate both sides. So we know in that tire, there are 3.95 times 10 to the minus 1 moles of nitrogen gas. Are we done? No, we're trying to get grams of nitrogen. And now we need step number 2, moles of N2 to grams of N2. How do we do that? Well, we have 3.95 times 10 to the minus 1 moles N2. We want to get to grams of N2, and I'll let you fill in what should be here and here. But in order to do that, I'll give you that. What's the atomic weight of nitrogen? And remember, an important information, test 2 and 3, 1 mole of a compound equals Avogadro, wrong part, 1 mole of a compound equals the molecular weight of a compound, and the molecular weight is the sum of the atomic weights. Your turn. Ooh, I haven't used this all day. All right, I think everybody's done, so I better get to work. Using your good buddy, your good friend, your analysis, whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. I'll write those in. One mole equals the atomic molecular weight of nitrogen gas. I've got atomic weight on the brain right now. I'll have to get it off. And you have 2 nitrogens in nitrogen gas. And the atomic weight of nitrogen to 3 significant figures is 14.0. Multiply it. So I have that number, and now I can pick up my calculator. And the number I get to 3 significant figures So if your car tire had that pressure, you would have 1.11 times 10 to the first grams of nitrogen, which is a little over 11 grams of nitrogen. Now, looking back here, I have 760 torque. Now, normally, your car tire pressure is actually double atmospheric, so it'd be double that number. So I should have gotten it right. And if we double the pressure, you probably have about 22 grams of nitrogen in each of your tires. I'm almost out of time. Now, remember, tomorrow, no class, no lab, it's in service day. And you can all sleep in late. Well, actually, I don't know if you sleep in that late since we start at 10, but if you want to, hey, you got my permission, at least for my class and all the other classes at COD. Remember, on Wednesday, I will do my world famous review for the next test, test number 2. And students say it helps, so please stop by. And finally, I am out of time. Don't forget, keep on wearing your mask. If you haven't gotten a flu shot, get one. And if you haven't gotten your vaccinations, get one. And with that, I'm going to say, gang gesund. Bye now. I'll see you on Wednesday, unless you come to my office hour tonight.